Hi, everybody. Welcome. Thanks so much for joining us for the beginning of the spring lineup for the CADIO webinar series. It's wonderful to see everybody on a Friday, our new date for this semester. As everybody's joining, I'll just set the stage a little bit for today. As you all know, this webinar is about Team CADIO questions and answers, particularly around the sorts of questions we get from reviewers in a grant proposal process. However, I want to say a few things just as we get started. The first thing is that all questions are welcome. It does not have to be about a reviewer question per se. Also, this is an extremely friendly sort of environment, so any range of questions is welcomed, and we encourage you to turn on your camera, unmute yourself and ask a question, raise your hand, engage in whatever way feels most comfortable for you. If at any point you want to submit a question for our consideration, we're really hoping this can be sort of an engaging time where we're directly addressing the questions that are the highest priority for everyone here. So please feel free to put a question in the chat. Again, raise your hand if you'd like, or if you'd prefer, you can send a question anonymously through a direct chat to Mia. And then Mia will put the question in the chat for us. And also I think Mia, but the rest of the team too, since it's a friendly crowd, just want to say hi, Linda. That's a great element of friendliness to kick us off. Thank you. The rest of the team will also help me keep track of the chat. And to the CADIO team, I'll just encourage you too to unmute and join in with all of this. So, without further ado, we'll start with the first sort of question that was motivating this whole webinar, but also a question that some of you contributed in our process of trying to get some questions in advance. This is a big one that we're getting a lot now. So the question is MOST still innovative? How can I respond if a reviewer points out that MOST is no longer innovative? How can I avoid this? How can I preemptively pitch the innovation in MOST without overdoing things? So for these questions, I'll say that we received in advance. We have some collected tips. We'll also talk about these things. And before I go into some of these tips, I just want to point out that there's a QR code on this particular screen. We have a new feature in our regular newsletter called Ask Caddy. That's sort of framed in your typical sort of advice column style with our friend Caddy. And one of the recent columns was about this question precisely. So if you'd like to see a written answer to this question or to see that as a supplement, you can feel free to use this QR code. But to launch into some of our tips around this question, and then I'll invite my fellow CADIO team members to join in. One tip might be to avoid saying that MOST itself is innovative. Instead, we generally recommend that people emphasize how their particular application of MOST might be innovative. This might be readily possible if MOST hasn't been applied in your particular area before, but it's also just really likely that there's something really innovative about the research questions you'll be able to address using MOST. I personally benefit a lot from the sort of organization presented in our Collins et al. Annual review paper. Maybe Mia, you can drop that in the chat for everybody. But that one emphasizes some key goals, including building the scientific base of knowledge and leveraging knowledge to identify high impact interventions. And of course, in an optimization context, these can mean many different things possibly, but I find this way of thinking can really help provide some structure for the innovation that might be possible through applying most. I'll pause there. Fellow CADIO team members, any additional input about this big question?
One thing I would just say is, just in the context of how your application of most is innovative, different ways you can think about that is, if most has been used in that area that you're looking at all before, or if you're doing it for the first time. And if there's a particularly thorny problem in the field that you're working in that nobody has really been able to kind of solve or find an evidence-based effective solution for, I think most is a great way. Using a most trial is a great way to think about, not necessarily solving that problem in this one trial, but starting to build up the evidence base to really push through that barrier in the field. So, just different ways you can frame it and think about it depending on what area you're looking at.
Great. Yeah, I think one of the reasons this question is so important, I'll just add, is that I already said that it's probably best to avoid saying that most itself is innovative. It could even be that a sentence that says that could at this point be a bit of a trip hazard, where a reviewer who's feeling a little cranky might want to latch on to that as something to kvetch about. So it might be, best to avoid for that reason as well.
Yeah, that whole innovation section, I think, in grant proposals is a little bit, I don't know, it's the part of the application that actually makes me the most uncomfortable in a lot of ways, because innovation is really not ever defined, and it's kind of in the eye of the beholder. And it is easy to get a reviewer's hackles up if you claim that something is innovative and the reviewer's like, well, no, it's not, that's not innovative. And the thing with most, I guess, is it's this year, 2025, is the 20th anniversary of the first publication related to most. That came out in 2005. And so if you just go by longevity, I guess, then, most is not new. So I think in some reviewers' minds, it can't be considered innovative, but it's kind of a catch-22 here in some ways, because although maybe you can't claim it's innovative, but at the same time you can't assume the reviewers know about it. So you you still have to include a little tutorial about most. It's funny, you don't have to include a tutorial about multiple regression, for example, but you do have to include a tutorial about most, because maybe it's not innovative anymore, but it's certainly still a very different way of thinking. And it also is not routinely taught in graduate education. So you can't assume that even, fairly new PhDs have had training in this area. So I guess I don't, is most still innovative? I think that depends on your definition of innovative, but you don't really, I guess you don't really get to define innovation in the grant proposal. So I think we've spent some time thinking about this, and I really like the advice that we're giving here, which is just don't say most is innovative, but emphasize the innovation of the kinds of questions in your own field that you can address using most. I think that's the safest way to go.
I'll just add to that. What you were saying, Linda, made me think too about how the same sort of advice also applies to the factorial design and the factorial family of experiments. To say that the factorial experiment is innovative, there might be the same appropriate cautions there, since of course factorial designs have been around even longer. And
yeah, more than 100 years in the case of the factorial design.
Right. And so a factorial design in a particular content area for a particular purpose may very well be innovative. But to just say we're using an innovative design might be the same sort of trip hazard that saying most itself is innovative is. All right. Yeah. Hi, Kimberly. Good to see you.
See you too. So I recently responded to a reviewer, and who, you know, went down this rabbit hole of not being innovative and took the advice from the website. It was super helpful. But the extra step I took was running a search in NIH Reporter, running a search in PubMed, and also clinicaltrials.gov, and saying, I found 0 studies using this approach in what I want to do. So here's the evidence that it's, you know, innovative. So you can't really argue with the numbers. So
Yeah,
that was and in their response in the second round, they were like, I appreciate you doing that work to show that it's not being used. So they took it well.
that's great. That's great. And thank you for adding that. It makes me think too that when you are saying that most has not been applied in your area, you have to be extra careful that that's actually true. And so
Right.
taking that step to do that search, you know, hopefully you don't wind up in the situation where you're saying that it hasn't been applied before and then you're having your grant reviewed by a bunch of people who know for a fact that there is an application of it in your area. But yeah, that extra step is a great one. All right.
Yeah, that's
We'll move
really great. And it just
we'll move
aligns, you know, just
yeah.
kind of, go ahead. Yeah. I was just going to say that really emphasizes your point of like really clarifying how your application of it is innovative. And people
Mhm.
can do that in really creative ways.
Yeah. Yeah. Okay, so another big question we receive a lot and that we received in the days leading up to the webinar is how can I communicate that my team, including myself possibly, has the needed expertise in most? Um, different variants of this. Do I need a biostatistician co-I? What expertise do the PI and biostatistician need to demonstrate? How do I know if I need a most expert on my grants? Um, so I'll just launch into this by saying that we always advise having a biostatistician on the team. And in particular, we advise having a biostatistician who's closely involved throughout the process. I always personally like to underline not just the power analysis, because that's a little bit of a complaint of some biostatisticians that they get called in for just that. But having a biostatistician that really is involved throughout can be a real strength. As far as expertise, one thing that might be worth underlining in the context of most is giving people the confidence that the PI is capable of a complex trial design with a lot of randomization and maybe more experimental conditions that people are used to seeing. This can be a reason sometimes it's nice to do a pilot optimization RCT to demonstrate that, though that's not always the step that people take. Um, and I'll just, before opening it up to the rest of the team, I'll just say we also have training resources available for biostatisticians, including a Coursera course that's aimed at methodologists. Because of course the optimization paradigm can require a new way of thinking for biostatisticians and methodologists as well. That said, the particular data analytic skills that a biostatistician might use in a factorial trial are not necessarily unusual. So one thing I also tend to recommend is that the grant might include a bit in that sort of explanation of most, explanation of things in general. There might be a little education for reviewers that the methods that are being used, things like factorial regression, say, are not unusual in terms of the biostatistician's skill sets. But I'll see CADIO leadership, any input here, and I'll also just say Jen specifically, any input as the successful PI of an R01. And am I correct that you did not do a pilot optimization RCT first?
Right. Yeah, that's correct. We had, I mean, there's two issues here. It's like kind of what your preliminary data is, but also, you know, the preliminary data kind of informs your expertise to, you know, your ability to be able to conduct the trial. So I would say, even though I didn't have a pilot, you can emphasize your prior experience managing complex trials, large cohorts of participants, any kind of large projects that you've run, you can emphasize, even if you haven't done a MOST trial, any of your RCT experience, and then your content experience in areas that are relevant for MOST. So whether that's really understanding barriers, the topic area that, of course, the content area that you're looking at, but also really understanding the barriers in those areas, developing interventions, evaluating interventions. And keep in mind that it's not just about the PI as well, it's also about your co-I's, experience that you're bringing together and putting together kind of like a puzzle that fits together so that you have all the requisite expertise that you need among the team, and then that you yourself have the experience of that you can illustrate of leading teams in large projects.
Great, thank you. Linda, can I ask for your input on the question, how do I know if I need a MOST expert on my grant?
Yeah, I think well, I think it depends on how much of a background you already have, and how much of a demonstrated background that is, you and other people on the team. There are lots of people now who have used MOST, who have conducted optimization RCTs, and you could always consider having someone as a consultant rather than a co-investigator on the grant, so that that person would be there as a resource. I mean, I'm sure almost no matter what area you work in, there's someone in a closely related area who has conducted an optimization RCT. If you can't find someone, contact us. No guarantees, but we know we have a broad network of people who are conducting optimization RCTs, and we may know someone in your area. If we do, we'd be happy to point you in that direction. So rather than a co-investigator, that's another approach to take.
Great, thank you. All right, moving to our next question. This is a big one, and my fellow CADIO team, I'll emphasize it as usual. Your input's valued here, but what are tips and tricks for avoiding confusion? And in particular, how can I avoid confusion among reviewers who might not understand MOST? Just a little earlier when we were talking about innovation, I found myself thinking about some new challenges we're encountering when reviewers have some understanding of MOST, enough understanding of MOST to criticize or contradict, but maybe not full understanding of MOST that would give them the full context that might help them understand what you're trying to say. So this is a new challenge, just in that you might have to provide some introduction to reviewers while also confronting maybe some misconceptions that select reviewers might have. A couple just key tips. The first is including a nice, clear conceptual model. And those of you who are with us today or watching this will know that we are all big fans of a nice, clear conceptual model, but I think the benefits cannot be overstated in the grant proposal, because reviewers really like to see that clear thinking, and it tends to help communicate a number of things very well. The justification for different candidate components, what's a candidate component, what's a constant component, if there's that distinction, what the hypothesized mediators might be, what the primary outcome is, if there are other outcomes. There's sort of just a lot that's communicated in a nice figure. We also always recommend including a nice, clear experimental conditions table. We always like if these can use color too, or maybe some shading to indicate the different levels of different factors. This can be a really nice visual way to remind people that the main effect for, say, a particular factor is estimated using one half of the sample versus the other half of the sample, something that can help minimize confusion about whether we're actually comparing individual conditions or combinations of conditions. We like to say explicitly that the particular design being used should not be considered a blank arm RCT, like if I'm doing a full to the fourth factorial and I have 16 experimental conditions, I might say this should not be considered a 16 arm RCT. And to further prevent confusion, I always recommend not using the word arm otherwise, other than in that one specific sentence. If you use the word arm to refer to conditions, it really lends itself to a sort of standard two-arm RCT way of thinking. These next two tips might seem really obvious, but they're very challenging. So making a clear pitch for optimization. This is really about telling the story of why do we need to identify the contributions of these different components? What resources might we save by eliminating insufficiently active components? What is the story here for why we're doing this versus something I have seen that sometimes lends itself to confusion is the sort of purely content-oriented pitch for intervening in a particular space that jumps right to, we're using most to do this. It's important to make sure that the content pitch is there, of course, but then there's a stepping through the optimization pitch that then leads itself to using most. And identifying a clear optimization objective. So am I optimizing to try to accomplish the best expected outcome? Am I trying to balance effectiveness on my outcome against cost in terms of minutes or something else? Am I doing that with affordability in mind, efficiency in mind? The more that objective can be very clear, the more confusion can be avoided. I'll pause there, see if there are additional questions about that, and also if my CADIO team would like to add further input.
I would just like to really second the couple of issues, like 3 things that you said, but just I would really emphasize, and it takes time to get to these, but the really clear conceptual model and being able to explain that, identifying your optimization objective, which is, you know, kind of hard, but really critical. And then using using the language that Jillian was talking about, condition instead of arm, things like that. But just kind of finding the language that you want to use to discuss your optimization objective, and then kind of repeating that same language in a few key places throughout the proposal will, I think, really help the reviewers to understand and help to clear up, you know, confusion. And I think, you know, one of the things that if you're doing this for the first time, going through this process and thinking through these different points will actually help you understand most more deeply, I think, and why the process is kind of set up the way it is. I think as you work your way through it, making a pitch for optimization, you know, developing your model, making a pitch for optimization, developing your optimization objective, and doing that really, you know, in a kind of linear, logical way, you'll start to learn more about most and understand why all these different pieces are necessary, and then you'll be able to communicate that more clearly to reviewers.
Great, thank you. Linda, any top tips for avoiding confusion?
Well, one thing I just thought of, I don't know why I didn't think of this before, but in my book, in chapter 1, and the book I'm talking about, for those of you who don't know, you can download a PDF for free from the Springer portal at your university library, most likely. Not every single university has it, but most do. There's a table that kind of compares the way people are using most think to the way the kind of classical scientist would think. And I think the reason I put that in there is really to help people who are writing grant proposals to kind of get into the mind of the classical scientists to get a sense of, what might they not be seeing unless I point it out to them. Just the very idea that you might want to look at a number of components and select among them, that, very fundamental idea in most, that's foreign to someone who's never thought of most and never thought that it was possible to do anything other than grab a big bunch of components and assemble them into a package and test the package. So, I mean, on the one hand, you can't spend too much time explaining everything about most, but on the other hand, I think it helps to try to put yourself in their mindset, the review, in the mindset, as to say, the mindset of a reviewer who's never even heard of most, and try and think of, what might they not even understand at all if I don't point it out to them, because there are some just fundamental differences in how we see things versus how a classical scientist sees things.
Linda, as you were saying this, I was thinking about something I've seen in a few instances. And I'll just pause also and say, if anyone wants to chime in with a specific question that might be relevant here, please do. But I'm curious, Linda, if you would give a little input on this phenomenon I'm noticing, where scalability is a real priority. And so an investigator goes to great lengths to try to make each component scalable. Maybe there's a digital component, or maybe there's been pilot work that's trying to make the component more readily scalable. And then there's the pitch for optimization. And a reviewer says something along the lines of, but you've already made each component scalable, so the whole thing is decently scalable. Why bother to optimize when you've already gone to great lengths to make each component scalable? Any thoughts about that or input there?
That's so interesting because underlying that comment, why since each comment since each component is scalable, why bother to weed out inactive components? Underlying that comment is the idea that it's okay to waste people's time, that it's okay to have, as many inactive components as you want in an intervention, as long as there's a detectable effect. Could be driven by a single component, and you might be wasting people's time for hours and hours with all the other components, but that doesn't matter. That just seems ridiculous to me. And in fact, lately, I've been wondering about the ethics of developing an intervention that has a bunch of inactive components in it. I mean, is it ethical to develop an intervention and then just expect people to be performing a bunch of components that are not, having any material effect? So I think efficiency is underrated in intervention science, and I think I would recommend to anyone to make the argument that, even if it's a digital intervention and each component is, once the app has been programmed, each component is free from one perspective. It's not free if you don't consider people's time free. If you consider that people's time have any value, then an inactive component is not free. And I think we should consider people's time valuable. That's my argument anyway.
Yeah. Thank you. Can I do the same thing and ask on a related note? I'm curious if you have, so in a digital context specifically, there is, I think, a ready case to be made that the more inactive components you have, the larger the threat to participants' engagement with a digital intervention, since engagement is such a big challenge with digital interventions. And I'm curious if you have any thoughts about raising this challenge as a pitch for optimization and the danger perhaps that a reviewer or someone at NIH or wherever will think that because engagement has now been emphasized as a real concern, maybe the experimental conditions that have more components in them will have systematic loss of engagement such that you're not able to estimate a main effect as well in the trial.
Whether that's a really interesting question. If that's a concern, and if the issue is that the components are delivered in a certain order, and so you might not get, let's say there's 4 components and people drop out and you might not get very many people completing the 4th component, you can counterbalance. I mean, that complicates the design, but I've seen people do it. It absolutely can be done. And so if there's that concern, that's what I would recommend, I think, counterbalancing.
Great, thank you. Okay, so on to another question. This one is certainly related to the confusion question, but how can I handle reviewer expectations that there should be a control group? My primary thought is that to a large extent, this comes down to that pitch for optimization, which is one of the reasons I say that this is so related to the confusion question. When you are taking these steps to sort of step out the pitch for optimization, do a little basic education about most, and a careful explanation of the design, that can certainly help with this. It can be useful to point out that each factor can contain its own control. So when we're estimating a main effect, it's for the higher level of the factor versus its lower level. And just, I think, making it as clear as possible to reviewers that we're talking about different effects here and different research questions that make the presence of a control group less relevant. All of this said, in some designs, there might be an experimental condition. So maybe 1 out of the 16, say, in a 2 to the 4th, that contains the content that a control group would receive. And you'll notice in the way I've worded this, I'm not saying there's an experimental condition that is a control group, because there isn't a control group, but there is an experimental condition that receives the content that a control group would receive. So maybe the design has all on-off factors, and that experimental condition gets all off, and whatever standard of care constant component there might be, or whatever is suitable to give to a participant who otherwise gets all off. And I just urge a lot of caution in how you talk about this to make sure that reviewers understand that we're not comparing that one specific condition to anything. That condition is part of the various combinations that go into estimating the main effects and the interaction effects, but this is not a control group per se. When we take the analysis to the point that we're estimating an expected outcome for each version of the intervention, so representing each different combination of factor levels, that means we're getting an expected outcome for this intervention that contains all off. And so that can be useful. But again, I just urge a lot of caution in talking about this specific intervention version. CADIO team members, anything to add? And also to our other attendees, feel free as always to add to the chat or raise your hand if you'd like to talk more about this.
This is probably something that should be covered in a grant proposal in around the same place where you tell them that this is not like 16-arm RCT evaluation RCT. I think those 2 points that that each in a 2 to the K experiment, each effect estimate involves all the participants, and that each factor has its own control. Those can be covered sort of near each other, because those are the 2 main aspects of the factorial experiment.
Yeah, yeah, great point. And this is one reason too, I was talking about the shading in that experimental conditions table that might really help emphasize the point that for a particular main effect, there's a comparison of different combinations of conditions versus specific conditions.
Oh yeah, and when you prepare that table, arrange the experimental conditions neatly. I sometimes see people, and they've just kind of randomly put the experimental conditions down there, and they make a nice pattern if you arrange them neatly. And the reason to do that is not just to be tidy; it's because it helps people to see the point you're making about
Yeah.
where main effects come from.
So Linda, you're talking about in the 2 to the 4th with 16 conditions. So factor 1 would have 8 on, 8 off. Factor 2 would have 4 on, 4 off, 4 on, 4 off, etc. So that
Yeah.
there's sort of that nice shape.
Yeah,
Yeah.
so you arrange the conditions so that in the first column, you see a big block of off and a big block of on, and then the next column, you see 4 blocks on, off, and so on. If you arrange the experimental conditions that way, I think it's just a lot easier for the reviewers to see what you're talking about.
How about there was another question that's a very common one about reviewers thinking that if you have an extra control group that you just add to the design, you could maybe pull off optimization and evaluation. Want to say anything about that, Linda?
Oh boy, that question drives me crazy, and it comes up a lot too, because people seem to want to, I don't know, there seems to be this pervasive misconception that you can answer every scientific question you have with one experiment, which, if you think about your training, you know that that's just not possible. But so, okay, just think about the logistics of that. So let's say you have, a let's say a 2 to the 4th experiment, 16 experimental conditions. Let's say you have, it's pretty well powered. You have 20 per experimental condition. So that's what, 320 altogether. So that's a decently powered optimization RCT. And now you're gonna say you're gonna add a control group. So now you're gonna have a 17th condition that is a no treatment control. Well, how many participants are you going to put in that condition? However many you put in that condition, you're going to be comparing that condition to an experimental condition that has 20 people in it, right? So one of the 16 experimental conditions in the optimization trial is going to be the winning condition, and that's going to have 20 participants. So how satisfying is it going to be to compare that mean to the mean of the control group? It just doesn't make sense. It's like a good idea in theory, maybe, but the only way to really have it work would be to seriously overpower the optimization RCT. You could if you put like 120 people per condition in the optimization RCT, then you'd know that you would have a large enough condition that you can compare to a control group, but you would have to have that for every condition because you don't know what's going to win. So it would just be hugely overpowered, and that completely defeats the purpose of the economy of the factorial experiment. So it's just not, when you really think it through, it's just not a good idea.
Yeah, and I think that there's no surefire way of preventing reviewers from thinking that way, but that sort of being very careful in how the research questions, the motivating research questions are pitched, has to be a key part of how that's done.
Can I just add that there's a related question that comes up, and that this happened to me once, but it was a decade ago, and I hope that this wouldn't happen now. But a reviewer, there are some people who think that if it's not an evaluation RCT, then it's a pilot study by definition. So which all of us working in intervention optimization emphatically disagree with. We emphatically disagree with that. Optimization RCTs are fully powered, sophisticated, carefully controlled experiments. They're not in any way pilot studies. But if a reviewer might be disappointed if there's no evaluation RCT because they feel that they don't see the value, the scientific yield of optimization RCTs. And so they might try to, in reviews, they might imply, well, this would be a lot more fundable if you kind of completed the circle and had an evaluation RCT in here as part of the 5 years of this R01. But again, when you think that through, it just doesn't make any sense, because what if none of the components end up being effective? Or maybe only 1 or 2 of them are effective, and you would need more in order to get an intervention that would be worth bringing to an evaluation RCT. So then what do you do if those are the results of the optimization RCT? So it just makes a lot more sense to apply for subsequent funding, either to do another optimization RCT or to do an evaluation RCT, because you don't know at the end, you don't know at the beginning of the project of course you don't know what the results of the optimization RCT are going to be.
Mm-hmm. Great, thank you. You know, as you're saying that, it also occurs to me that our use of the optimization RCT and evaluation RCT language is still relatively recent in terms of the sort of recommended terminology, but we've been finding that this can be really useful in a grant proposal context to remind reviewers that the optimization trial being proposed is in fact an RCT. And that's not just according to us, but also according to NIH and others. It's a randomized powered design that involves these sorts of comparisons. And so we like to use the optimization RCT as a further attempt at minimizing reviewer confusion. But I'll just throw out there on the terminology note that then requires that you also use the evaluation RCT language if you're going to contrast the two. And you might even want to use, you know, classical 2-arm evaluation RCT or something like that. I've seen a couple cases where people try saying things like a regular RCT or fall into just using more traditional RCT language. And if you're using optimization RCT, it then sort of dictates using the careful contrast of a 2-arm evaluation RCT as well. All right. How can I approach reviewer concerns about cross-contamination when providers deliver different components? This is another really big question. Unfortunately, this is a question where I think I can speak for the full CADIO team in saying we frequently wind up saying something along the lines of "it depends." But we also recommend another of our webinars led by Dr. Nick Odom, who gives a lot of practical advice about how he has managed some of these challenges, the sort of more practical logistical side. The QR code here takes you directly to that webinar recording if you're interested. I'll also just say that Of course, a big part of this is very careful protocols and procedures that can be communicated to reviewers, and it can be useful to think about what makes this concern more relevant with a factorial experimental design versus a two-arm trial. Because I think if we think carefully about that contrast, like what is it that's more concerning in this factorial design, it might help then to inform what the protocols need to look like. Um, anything, my CADIO team, anything to add here?
Yeah, I would just add, I mean, I would emphasize a couple of things is, you know, when you're designing your components, whether that's in your pilot or, you know, for the optimization, this is where you really want to have that strong conceptual model where you're thinking about all the time, like how does this component specifically target these one or two mediators with every bit of content that's in that component? How are we targeting these one or two mediators and ensuring you're not targeting the mediators that the other components are designed to target? So in that design piece, and then ideally in a pilot where you're testing, really focusing in on that kind of precision of each component. And there's different things to consider depending on, you know, how granular or how kind of higher level your components are. But I think keeping that framework in mind the whole time when you're designing is really, and then being able to test that is really helpful. And then, you know, once you are running the trial, and Dr. Odom covers some of these things, having component-specific manuals, like really clear, whether it's manual or curricula, protocols, checklists. If you're doing something digital, having a digital tool that your interventionist can use to kind of walk through the delivery of those components when they're doing it, so they don't, especially if you have the same provider providing different components, they have a manual for each one that they can use so they don't kind of cross into the other component and what it's targeting. So that's one thing. And then in relation to that, and some of these things are things that you would do in a regular RCT to reduce contamination, but they're just more important in most. And then you also have these, you know, kind of issue of a more precise targeting of mediators. So you just keep all that in mind in terms of like a training protocol. You want to have a clear training program, maybe considering, you know, if you have a provider providing multiple interventions, multiple components, you might want to have component-specific training, focusing on one component at a time and emphasizing the features that make that component really distinctive and the mechanisms, the mediators that you're targeting. And then, you know, clarify kind of if there are, you know, what the distinct boundaries are. Like if, say, for example, if you are targeting this, you know, and again, this depends on kind of the level of granularity of your components, but if you are targeting norms, different kinds of norms, that's where you, in a, you know, behavioral or other kind of intervention, that's where you want to be really clear on the boundaries between different types of norms that are being delivered or addressed, whether it's inductive, descriptive, whatever, or motivational interviewing versus cognitive behavioral training, just being really clear on those differences when you're training them. And then doing formal assessments of those trainings and kind of assessing their ability to distinguish between. And then when you're running the trial, things like fidelity monitoring of the components, you having them, this could be post-session documentation, things that they're filling out after the session to see if they're covering certain topics in each session and not going into other areas. And having notes from them too after sessions, so you can kind of learn about the challenges, so you're learning along the way. And if you have, if there's a possibility, you could record sessions and get a random sample of those and have some kind of coding system that's capturing the specific mediating mechanisms that that component is targeting. So for each component, if you can do that for the delivery, and then you can code those and assess are these sessions targeting the mechanisms they're supposed to be targeting and not targeting the mechanisms they're not supposed to be targeting. Those are helpful fidelity monitoring, and having metrics to capture that. And then the last thing I would say is just, ongoing support. So you've done the training, you have the monitoring, but you want to be using that information you're collecting, on a regular basis to provide support for the provider in answering questions and providing constructive feedback and helping them to, improve their ability to deliver each of the components separately. And if you can, and this can get tricky, but if you can provide one thing to do that might be helpful if you have a provider who's providing several components is maybe having them receive feedback and supervision on each component from different people, so that you don't have a single, supervisor providing all the feedback and they might be contaminating, their supervision and feedback across components. And if you have a separate person, whether that's an expert, ideally an expert in that component who's supervising and providing feedback for that component, and then for the others, another person for the other component. I think those can be good ways to think about, reducing the concerns about cross-contamination and, and reducing reviewers' concerns about that, just having these ways to put it in. So, I guess summing up, just like the design, thinking about this all the way through from the design to, initial implementation, training, monitoring, and, ongoing support. Putting these different strategies in and thinking about them in a most way, I think can definitely reduce those concerns. I know on my grant, I did some resubmissions, and those resubmissions were addressing very specifically those kinds of questions from reviewers. And I actually had different providers providing different interventions components, but there were still concerns about that. So we put in, some of these approaches, and that seemed to reduce their concerns. And then I would also recommend looking at Dr. Odom's webinar is helpful. He has some other ideas there as well.
Great. Thank you. So this is sort of bringing us to the end of the questions, the big questions we received leading up to this webinar. If you have a last minute question, oh yeah, I see one. Alessio, hi. Is there a checklist that can be used for the co-development of a MOST trial? That's a great question. Jen and Linda, can you think of a checklist for so Alessio, can I ask, you're talking about co-developing the trial itself, not co-developing the intervention, or co-developing the intervention that will be tested in the trial? The trial. So co-developing the trial. And can I also ask, co-developing with whom? Yeah, no problem. No need for the camera, but I'm curious. So the intervention scientist co-developing the trial with an industry partner. Yeah, I can't think off the top of my head of any sort of co-development oriented checklist. Can you, Linda or Jen?
No, I'm not sure. I'm not totally sure what the difference is between developing and co-developing. Are we just talking about a checklist for developing the trial?
Well, I think it would be developing the trial in a way that has equal input from a key partner in the trial process. And that's so development of the trial with different stakeholders.
Mm.
Yeah, this is a really interesting question, because I think that key partners and stakeholders can be involved in a number of ways that do impact the trial design. So in terms of the number of candidate components and What levels do the factors for components have? And is there a constant component that everyone agrees upon? And what is the primary outcome? Are there additional outcomes that should be measured? These are things that I think in most of our conversations about optimization, we tend to think about this in terms of the intervention scientist making these decisions. But it's absolutely true that other stakeholders could have input, and I do not believe that there is a checklist for that yet. That said, there are some checklists surrounding the preparation phase.
Yeah.
And I don't know that we have these as readily available that I could ask Mia to add them to the chat on the spot. But if you send me an email, I can connect you with some of the preparation phase oriented checklists that might be relevant for the trial design as well.
Yes, I was
Yeah.
just thinking about that, like the aspects of the preparation phase are really where you can bring in different stakeholders in helping think through all of those issues. You know, starting to identify components, developing the criteria for selecting components, developing your optimization objective, deciding on you know, how to select the components for your trial. That's I think built for, you know, kind of stakeholder involvement, that preparation phase.
Yeah, sure thing. Well, we're about at time. Thank you to everybody for your attention. I just want to highlight the next webinar in our series on February 21st, led by Dr. Karina Mushiro. We hope to see you all there, and we thank you so much for your time and attention today, and happy Friday.